Hey class, welcome back. Geography 101. Today's fluvial geomorphology and the operation of rivers. One of my favorite subjects, a little harder to talk about here in Los Angeles because our river is largely a concrete ditch, but we'll talk about it anyway. So, as we always do, learning objectives first. These are the things that would be nice if you could do by the end of the chapter. Here's some basic concepts. Hydrology, that's just the science of water. Global circulation, distribution, properties, and if you're a hydrologist, you probably are in the geography department. Most of the geographers that study hydrology study surface water, and some do groundwater hydrology. Those geographers in this department are fluvial geomorphologists, and the word fluvial means river. Geomorphology means the shape of the earth, and so fluvial geomorphology is about how rivers shape the earth. Two major driving forces: insulation, so rivers actually begin with the hydrological cycle, rain, and then gravity. Billions of gallons of water moving between the lower atmosphere to several kilometers beneath the Earth's surface, and the vast majority, of course, is in the ocean, but that part that's in rivers play an exceptionally outsized role for human development. Most cities are on rivers. Most agricultural, or a great deal of our agriculture, is irrigated with rivers, and a significant proportion of drinking water comes from rivers, even though, as you may recall from earlier, it's more likely to be polluted, and so we would not like to do that. Some vocabulary associated with this graphic. We have up here in the upper a drainage divide, which is essentially just a boundary between where rivers in one direction flow over another one. Sheet flow is what water that is flowing over ground but not channelized is called. They start with rills, turn into gullies, and eventually the water that's in a gully, if it does have water, eventually becomes some kind of a stream. Here in the bottom graphic, again, another drainage divide like we had at the top, and all of the water within a drainage divide flows into a watershed or a drainage basin. They're essentially the same words. These little areas between these streams are called interfluves. Drainage basins can be extremely large. The largest in the United States are divided by drainage divides called continental divides. The continental divide, as folks call it in everyday lingo, is this one here that divides the Missouri, Arkansas, and some of these other ones that flow east from those that flow west. But there are different ones from various spots that divide major drainage basins. You'll notice in this photo that the United States and Canada don't have to worry about too many of these continental divides crossing our national borders. We're good friends with the Canadians, and we can trust them probably more than they can trust us on water quality issues, but for the most part we don't have to worry about that. If you go to Europe, though, and you take a look at the course of the Danube, this area in green is essentially the watershed for the Danube River. And if you look at the number of countries that are falling inside the Danube's drainage basin or the Danube's watershed, you see that it's significant. The Romanians here at the end of the river, at the mouth of the river towards the delta, have to use the Danube River despite all of the possible damage done to it by the Germans and the Czechs, the Slovaks, Austrians, Hungarians, Croatians, Slovenes, Bosnians and Serbians, Kosovars and Montenegrins, Bulgarians among the others. So these can be really quite contentious. Dams built in one part of the river can dramatically affect the lifestyle of the people living downstream. Most streams flow into the ocean, or at least into a bay or a massive lake that drains into the ocean. There are some that don't. And those that don't reach the ocean have an internal drainage basin, and there are a handful of those in California, particularly the playas, Playa, are found out in the desert, and they frequently become these massive saltine or salty dry lake beds. In those areas, there is a low level of drainage density in those desert areas. But a humid area where there's lots of rain and not a great deal of evaporation, you have a great drainage density because there's a lot of streams versus the area of the drainage basin itself. And then you should know a little bit about that, but also about the drainage patterns. So we'll take a look at some of these drainage patterns. I'm not sure, and this is a term used by the book, that these are common. There are multiple drainage patterns, and I would say one of them is really quite common and the others are evident or visible. The one that's really common is dendritic drainage. Then there's trellis, radial, parallel, rectangular, and annular. And my favorite one, deranged, but we'll talk about those momentarily when we look at each of the images in sequence. The dendritic one looks like branches of a tree. In fact, dendritic is a reference to trees. This is an efficient system. The overall length of the branches is minimized, and this is an area, these appear in areas where the river can erode freely across space. These other drainage systems usually are captured by the underlying bedrock. And so in areas where there's a lot of dipping and folded topography, terms you should know from earlier chapters, particularly something like the Great Basin in Utah or Eastern California, where there's the rolling Horst and Graben system, you will find this sort of drainage system. You'll also find it in the ridge and valley system of the eastern United States, parts of Tennessee, but also the great Cumberland Highland area. A radial drainage system would be found around a mountain. So here, where I'm drawing this X, is the peak of the mountain, and all of the water that would fall, or snow would fall here, would begin to run off in various directions away from the peak of the mountain. But notice that this is also a kind of dendritic systems moving away from this central peak. This is another kind of dendritic system, but one that is usually found on steeper slopes. So the pattern, the branches are narrow. So these would be sort of skinny trees if they were using the dendritic metaphor. Rectangular drainage is another one of those found over the bedrock that captures and channelizes the streams into these cracks in the rock that can be eroded more easily. Right turns, left angles at 90 degrees are generally unusual in nature, but the way that some bedrock degrades and cracks will create rectangular drainage systems. Annular drainage, pretty unusual. So you've got, again, a hillside, a mountaintop here in the middle, but the type of rock that is on the hillsides has some of these characteristics because of the joint block separation or erosion. Rocks that degrade or break apart in squares will produce this odd annular drainage. And then the last one, deranged drainage, is the kind that you sometimes will find in areas that are flat and have been glaciated. So like the area of the Canadian Shield. There isn't a great geometry to it and very little true pattern that can be discerned. It's just sort of random.